We're doing capacitor. We'll be doing both in series and what? Parallel. We'll be doing resistor. Both in what? Series and parallel. I wanted to do gas law, but no problem. AMF. We're supposed to do all this before we jump out from this topic. We'll be doing what? Ohm's law, capacitor, both in what? Series and parallel, resistor, in series and parallel, EMF, resistivity and conductivity. I start writing. Right. That's what I'll call now. Please, no more noise. I like how this weather is cool. Oh. If you make noise now, it will scatter. Are you starting? All right. Right. Ohm's law. Ohm's law states that. Okay, I should not move far. Sorry. I should stand there. I like pacing. Oh, wow. Again. Ohm's law states that the current I, the current what? I on the board. You and I flowing through a metallic conductor. The current I, you can say the current, comma I, flowing through a metallic conductor is directly proportional to the what? To the potential difference, comma V. To the potential difference, comma what? V. Across its ends or terminals. Across its ends or terminals. Ohm's law states that the current I flowing through a metallic conductor is directly proportional to the potential difference V across its ends or terminals. Mathematically. V is directly proportional to what? I. V, the rule states that this sign will shift. And once the sign shifts equal to and a constant enters, the constant can be represented as K or C. But in Ohm's law, we are dealing with resistance of a resistor. So instead of K entering, R will enter instead. So we have V equal to RI or V equal to IR. Now, if you're making I the subject of the formula, what will happen? First of all, you put something here. The relationship is what? Times. If times is crossing, change to what? Division. Where I, V, and R, where I is the current and is measured in what? Ampere. V is the what? Potential difference. And is measured in what? Volts. Is it only potential difference? Can also be called what? Voltage. And is measured in what? Volts. R. What is R? Very good. Resistance of what? A resistor. And it's measured in what? Ohms. What do you say? Ohms. And the symbol is what? Looking like we. Say ohms. And not say Shimono. Okay. Very good. Very good. Now, before we jump to this capacitor, splitting it in series and parallel, we have to know the types of cells we have. Number one, we have primary. And what? Secondary. What is I again? And it's measured in what? Ampere. What about V? Or what? Or voltage. What about R? And it's measured in what? You're not calling it that I call it though. It's measured in what? Okay. For primary cell, these are types of cell under battery. Now we have primary and what? Secondary. Now we'll pick for primary. Primary cell, right? Are those cells, this I should not move too much. Are those cells from which current is induced? Are those cells from which current is induced? INDUCED. Induced as a result of non-reversible chemical changes. Are those from which what? Current is what? Induced as a result of non-reversible what? Chemical changes. How many types of changes do we even have in matter? Physical and what? Chemical. Which one is physical? Which one is chemical? That can be reversible. And no new substances are formed. What about chemical? Is it not reversible or is not easily reversible? It can be reversed, but it's not. You can't do it like that. Do you understand? So it cannot be easily reversible. But the other one can be easily reversible. Example of physical change is what? The solution of salt in water. Very good. Which other one? Freezing of ice cream. Sticks. No, that one is chemical. What about candle wax? What else? Okay. What did I say is primary cell again? Talk to me. Primary cells are taking place between the various components of the cell. Taking place between the various components of the cell. Full stop. Now, for primary, right? Sorry, for secondary. This could. Secondary. They are called accumulators. They are also called accumulators. secondary cell, they are also called accumulators. Full stop. These are types of cells. These are types of cells whose chemical actions can be reversed. These are types of cells whose chemical actions can be reversed by driving a current through them. By driving a current through them in a direction opposite in the current they supply. They are also called what? Accumulators. These are cells whose chemical actions can be reversed by driving a current through them in a direction opposite to the current they supply. In a direction opposite to the what? Current they supply. Full stop. By driving a current through them in a direction opposite in the current they what? Supply. Full stop. Types of primary cell. Number one, we have is what? Leclerc. And what? Some people call it Leclanche. So it's only two. First one is what? Daniel. And the other one is what? Leclanche. Example of Leclanche is what? Example of something that is Leclanche, that has Leclanche is what? What? Yes, touch battery. That Tiger battery, you know. You know that Tiger battery now? That one. Can you plug that one in electric for it to recharge? No. So that one is example of what? Leclanche. Are you listening? Then accumulators are what? Example of secondary cells. And where can you see accumulators? Let's acid accumulator from where? From phone, car now, car battery. So these are examples of secondary. Are you following? Everything is not there. Let's write. Listen first. I believe if I say something, you grab it. You don't need to write anything. Are you following? Are you following? All right. Who is confused? I should call the examples again. Examples of primary cells are Daniel and what? Leclanche or Leclanche. Now I was going to give you an example of Leclanche cell or Daniel cell. Is this battery your torch has? Or battery your radio? Radio, this old radio, that big Tiger battery, you know now. Some people, after when the battery will run down, they will bring it outside for it to charge. Nothing is happening, you know. No, nothing is happening. Seriously, nothing happens. Calculator battery, it will be also part of primary. Because once it is worn out, you need to change it. Okay, there's one I used to charge. This one. I don't know that one. No. The one we know. If we're talking about calculator, we're talking about WAEC now, CAPEC. So that battery in CAPEC is like watch battery now. Once it is worn out, just need to go and change it. Simple. Now we move to capacitor. Some people find it so hard to know when it is in series and when it is in what? Parallel. Right? We'll break it down now. Not about saying amen. There's two things I hate. If I say something, so the person will say, it's true. It will look as if I don't know what I was doing before. Another thing I hate most is if I'm saying something, they'll start clapping. I don't like it. And this amen you just said. You know why amen looks like it doesn't work? Amen will look like it doesn't work because I believe if you don't do anything, you can't see the result. Just like how Darlington was teaching that day. Without action, There will be no reaction. If you don't read, I don't believe in miracle. Yeah, let's continue. Capacitor, capacitance, and what? Capacitor in series and capacitor in parallel. I think we're in lesson. So now, we're moving. Who clean the board? I'm too young to be cleaning this board. Who picking first? Is it in series? Alright, in series. Who is with first question here? In physics. Very good. Open to this page. Open to this thing. Yeah, this is C. Look at the board. What did you notice? What did you notice? Oh, yeah.
Resistors in series is the same with capacitors in parallel.
Okay.
Resistors in parallel.
So in essence, it's okay. So in essence, no more noise. Capacitors are the opposite of what? Resistor. Now, what you do for me is to know at least one of them. If it's capacitor you want to know, for JAMB students, listen, know. If it's for capacitor you want to know, thank you. This one is capacitor in series. Remember that it is 1 over CT. Once you have known that this one is for series, if you see resistor in series, change it as the opposite. If this one was 1 over, then in series, it will not have 1 over again. Do you understand? Do you understand? That is how you can know it. Now go again. I said capacitor in series is what? 1 over CT equal to 1 over C1 and the rest. If you can know that this one in series has 1 over, if you are now looking for resistor, let's say the question came in resistor. Since you have remembered that capacitor in series has 1 over, therefore resistor in series does not have what? 1 over. And if capacitor in parallel does not have 1 over, resistor in parallel will do what? Have 1 over. Do you understand now? This is the secret to knowing it. So in essence, capacitor is the opposite of what? Resistor. So if they tell you find this, this is the first problem I think students normally have. After knowing this one now, I think everybody will know it now. Even if it is only one, even if you can know only capacitor, just know it. Remember that in series it has 1 over, but in parallel it doesn't have. So just know that one first. So if you are now solving resistor, do the opposite. Now another one we're going to know is when capacitor is in what? Parallel, and when capacitor is in what? Series. All of them are the same thing. The only problem is just the formula. If you can know where this one is in parallel, there's no problem. If you can know when this one is in series, there's no problem. Now, what's the drawing? For capacitor, in what? Parallel. Okay, let's use series first. Draw what I'm drawing. Oh. And C3. This one is for what? Series. This thing. You people are now mistaking this thing. I told you, the only problem is having is just the formula. In series is the same thing. Once you can find this thread, this is in series. But in parallel, it will have joining. The only problem is just that this formula for this one has 1 over. Series is series, parallel is parallel. The word are the same thing. But the only problem is just what? The formula. The way this one is arranged in series is the way it will also be arranged in resistor. Do you understand? Do you understand? Now for parallel, this one is for parallel. The same way in resistor. Yes. Okay. Capacitor in series is the same thing as resistor in parallel. Yes. Series goes to parallel. Parallel goes to series. The capacitor in series is the same, almost the same way like resistor in parallel. Then the capacitor in parallel is the same thing as resistor in series. Yes. It's just the opposite. That's why I say you should know one. If it's a resistor you feel like knowing, then you know that one. Are you following? Alright. It can also be drawn like this. Now I want to explain it the way you understand. Okay, now for series, for parallel, sorry. If you use this box to draw here, if I'm using this way, then you do the same thing in case you want to do it in your book. There's no space again. So in case you want to draw this type, once you get here, you do the same thing and draw. But there's no need. Just know it. Everything is not copy, copy, copy. After copying now, you not read this thing. I know. Okay, are you through? Copy fast. Let me explain something. Copy fast. So I'll explain something. Is it literature? Okay, it's literature. Business study. Okay, CCA. This drawing, I explain something. Look at the board. Bye bye. Look at the board. If I should give favor this end now, if I should give favor here and tell favor, take this thing, let me hold here. Go to this side, let me go to this side. Will it be straight? It will be straight. Eh? Answer now. I told favor to hold this wire. Let's say this is a wire. I told favor hold this wire from here. Let me hold here. I now told favor go to this way. If favor should go that way, will this wire be straight? It will be straight, Abi. It will be straight. Very good. Now, in your imagination, if you are solving, just imagine I'm holding this wire. No matter how the drawing comes, what I want to explain this thing. When we will not be solving, I will not be telling you. If you hold here, you imagine that another person was holding here. Whether the drawing is coming like this, and there is this, and this. And you just tell yourself, if I should lose this place now, give it to this girl, it will bend like this, Abi. Are you watching it? Here we bend, Abi. Now tell her, favor, take this place. I want this wire to be straight. Hold it and go there. Favor will take this end. Move. As she's moving, here that was bent will straight like this, Abi. Here that was bent like this will also be straight. Here too. As I'm moving too, it will be getting straight. So no matter how the drawing is coming, if you check it with your head, if I should hold there and hold there and start drawing it straight, will there be any entanglement? If there is no entanglement, then it is in series. But in case you hold it here, what you? I'm just doing freehand sketch. Now watch. If I tell favor to hold here, and so that I'll hold here, so we'll stretch this wire, so that this wire will become straight. Will it be straight? No. Watch. Favor hold here, favor hold here. As she's coming to here will not even straight, because there's entanglement here. Are you following? So before here will get straight, here will be fixed, here will also be fixed, here will also be fixed, and here will also be fixed. So if you imagine that if I hold this thing and start opening it, or let's say you open here. Okay, let's forget this one now. Open here. If you're opening here we bend. Once here bends, for it to bend here now, it will meet somebody here. It's not going straight. It will not have two wires here. But the rule states that it must be one. Now, if you check it and check it and check it, it's not forming any straight line, then it is in what? Parallel. But if you open it and open it and open it and open it, and it's forming straight line, then it is in what? Series. Do you understand? The same way with resistor, the same way with capacitor. That is the only way. There's no differences between series and parallel, just the formula. Now it's now left for you to know, is this thing in series, or which one and which one are in series, or which one and which one are in parallel? Do you understand now? We are coming there. I'm just trying to explain this thing. Now, look at this first question here. It's like a drawing. Okay, it's something like this. They said, the question says, The equivalent capacitance of the circuit drawn below is, are you writing? Okay, question number 1. The equivalent capacitance. The equivalent capacitance of the circuit drawn below is dash. The equivalent capacitance for the circuit drawn below is dash. Then look at the circuit that was drawn below. There is 5. What is this, class? What is this thing? Microfarad. Very good. Very good. Very good. A micro is how many? 10 times 10 raised to power what? 6. Abi? Is it times 10 raised to power minus 6 or 10 times 10 raised to power 6? Okay. Micro is not minus, so it's 10 times 10 raised to power 6. But if you're now dividing it, it might now have minus. Because in some cases, you want to convert it to farad. Then you're dividing, let's say it was 4 over, then 10 raised to power minus 6 is million. Abi? 10 raised to power 6, sorry, is million. Then if you're now dividing it by 10 raised to power 6, then it's now having minus. Because for this divided by this thing, we have 0.000000. Are you following?
Yeah.
Now look at the circuit drawn below. Now let's check. Look at this thing now. Look at it. Remember, they told us to find the effective capacitance in the what? Circuit drawn below. If I should hold here and hold here, is it forming straight?
No.
It's not forming straight, Abi?
Yeah.
There is a problem here.
Yeah.
Abi?
Yeah.
Now these two things are in what? Are in parallel. Are you getting?
Yeah.
But if they are here, here, and here, then they are in what? Series. So we have 2 parallels here and 1 series. The rule states that all of them, no matter what you do, they must be in series. So now how do we make this thing to be in series? Now we're now coming back to WAEC students. After drawing it, okay, they showed you the diagram. You have finished drawing the diagram in your book. You start solving. Remember, what did the rule says? The rule says that no matter what you do, all of them must be in what? Series. Now, since these 2 things are in parallel, we have to convert it to parallel. Now, join it with this one so that they will be in what? Series. Now, what is the formula for capacitor in parallel? C1 plus C2. We're stopping at C2 because we have only 2 capacitors here. Now, C1 is what? 5 plus what is C2? 7. And 5 plus 7 is what? 12 what? Microfarad. Now, I've gotten 12 microfarad for it in parallel. For WAEC students, you will draw it again. What is here? Now, these 2 things are now in series. What did we get? 12. So you put it here. Do this thing the way I'm doing it, oh, if you don't want to have accidents. Now, they are now in what? Series. I can hold here and hold here to form straight line. Abi?
Yeah.
Very good. Now, we can now find the effective capacitance. What is capacitance in series? 1 over CT is equal to what? 1 over C1 plus 1 over C2. C1 will be this, C2 will be this. 1 over CT is equal to 1 over 6 plus 1 over 12. If a fraction has plus, what do? You find the LCM. What is the LCM of 6 and 12? 12. 12 in 6 times 1 plus 12 in times 1. 1 over CT is equal to, what is 2 plus 1? 3 over what? 12. At this juncture, we're looking for CT, not 1 over CT. What we're looking for is just CT. But what is here is what? 1 over CT. What do? Write it. if you do this thing in WAEC, they will not look at you again. No, they'll say, oh, this guy cancelled this side. I'm serious. Oh, I'm serious. Don't do this thing. Oh, even if you cannot write this thing, just do what you are doing. Don't do this thing. Just continue solving. Even if you cannot write cross multiply, continue solving. Because once you do this thing, you say, oh, she said there was mistake here. And they will jump here for you. Okay, they don't have sense. Cross what? Multiply. If you cross multiply, only me has the power to do this thing. Only me. So I'll do it. Now, CT with times 3, 1 with times 12. What is CT times 3? You are doing very well. Very, very well. What is A times B? And what is B times A? Hey. A times B is what? AB. Then B times A is AB. Okay, 3 times CT. No, say CT3. It's equal to 1 times 12. Divide both sides by 3. That is primary mass. Just keep CT is equal to this. The relationship is times. Once times is crossing equal sign, we change to what? Division, which is equal to what? 2 times 2 times. What will you get? 4. So it becomes what? 4 microfarad. 4 ohm resistors connected in parallel have potential difference of 16 V, 16 volts applied across them. 16 V applied across them. Full stop. What is the total current in the circuit? What is the total current in the what? Circuit. What is the total current in the what? Circuit. Should I call option? Should we call A 3A, B 2A, C 5A, and D 4A? 3, 2, 5, 4. Total current. All right. Let's solve. How many 4 ohms? 3. And they are connected in what? Is this series of parallel? What is the drawing of parallel? For WAEC students, you are going to draw. One is what? 4. Another one. Another one. 4. Neglect my drawing. Capacitor, resistor in parallel is what? 1 over what? RT is equal to 1 over 4 plus 1 over 4 plus 1 over 4, right? Which is equal to, we have 4, 1 plus 1 plus 1. True or false? Which is equal to what? 3 over 4. Now, if 1 over RT is equal to 3 over 4, therefore, RT is equal to what? 4 over 3 ohms. Let's not put it in decimal yet. Let's leave it like this. Okay. Remember, they gave us in the parameters. They gave what? They gave potential difference, which is PD, to be what? 16 V. Now I've gotten our R to be what? 4 over 3 ohms. And what did they say we should find? I, unknown, which is in what? Ampere, right? What formula connects V, R, and I? Ohm's law. So which is what? V is equal to IR. And I is equal to what? V over R. What is V? 16 over what is R? 4 over 3. Right? Without calculator, don't touch. So we have 16. This is 16. What is over? Divide. By what? 4 over 3. 16 is in your question. So if 16 divided by 4 over 3, in fraction, if you're having division, what happens? It will change to what? Times. After changing to times, the rich man becomes the poor man, and the poor man becomes what? The rich man. 4 divided by 4, 1. 4 divided by 16, 4 times 3, 12 what? Ampere. It's not in the option. So this is the answer. This is the what? The option is 3A, 2A, 5A, and what? 4A. Others will have been solving. I will solve it in option. Only this one. Alright. They are wrong. And we are right.